The question addresses the use of a white wire as a switch leg or traveler, specifically in relation to the National Electrical Code or NEC, particularly the 1999 and 2002 editions. The concerns stem from the potential confusion and electrical hazards that could arise from using the white wire, which is typically designated as the neutral conductor, for purposes other than carrying neutral current. It's important to understand the relevant code sections to ensure safe and compliant electrical installations. In the 1999 NEC, there wasn't an explicit prohibition against using a white wire as a switch leg or traveler. However, the code did require that if a white wire were to be used for such a purpose, it had to be permanently re-identified to indicate its function as an ungrounded conductor. This re-identification typically involved marking the wire with black or red tape or paint at each termination point, effectively signaling that it was being used as a hot conductor. The reasoning behind this requirement was to prevent electricians and others working on the electrical system from mistakenly assuming that the white wire was a neutral conductor when it was actually carrying current. The 2002 NEC introduced a more stringent requirement regarding the use of white wires as switch legs or travelers, especially within multi-wire branch circuits. Section 200.7 Kern of the 2002 NEC directly addresses this issue, stating that white or grey conductors shall not be used for switch legs or travelers unless they are identified by marking or other effective means at each termination. In simpler terms, the 2002 NEC maintained the requirement for re-identification but clarified its applicability to switch legs and travelers. The underlying concern remained the same: to prevent confusion and potential electrical hazards. By requiring clear identification of white wires used as hot conductors, the code aimed to reduce the risk of accidental contact with energized wires and ensure that electrical systems were wired and maintained safely. The NEC stance on this matter underscores the importance of proper wire identification in electrical work. Color coding is a fundamental aspect of electrical safety, as it helps electricians quickly and easily identify the function of each wire in a circuit. Using white wires for purposes other than neutral conductors can disrupt this color coding scheme and increase the risk of errors. The re-identification requirement is intended to mitigate this risk by providing a visual cue that the white wire is not what it appears to be. It's important to note that the specific requirements for wire identification can vary depending on the jurisdiction and the specific edition of the NEC being enforced. Electricians should always consult the latest edition of the NEC and any local amendments to ensure that they are following the correct procedures. In addition to the NEC requirements, it's also important to follow best practices for electrical safety. This includes always energizing circuits before working on them, using appropriate personal protective equipment, and carefully verifying the wiring before energizing a circuit. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others. The changes in the NEC regarding white wire usage as switch legs or travelers reflect an ongoing effort to improve electrical safety and reduce the risk of electrical hazards. By understanding the rationale behind these changes and following the code requirements, electricians can help to ensure that electrical systems are installed and maintained safely and correctly. The purpose of the National Electrical Code is to establish a minimum standard for electrical safety. It is updated every 3 years to reflect changes in technology and best practices. Local jurisdictions may adopt the NEC as is, or they may make amendments to it. It is important to consult the local electrical code to ensure compliance. An electrical circuit consists of a source of power, a path for the current to flow, and a load. The source of power is typically a generator or transformer. The path for the current to flow is typically a wire. The load is typically a device that uses electrical energy, such as a light bulb or motor. Electrical circuits can be either alternating current or AC, or direct current or DC. Alternating current is a type of electrical current that reverses direction periodically. Direct current is a type of electrical current that flows in one direction only. Most electrical systems in homes and businesses use alternating current. Electrical circuits are protected by fuses or circuit breakers. Fuses and circuit breakers are designed to interrupt the flow of current in the event of a fault. This helps to prevent electrical fires and other hazards. Electrical work should only be performed by qualified electricians. Electricians have the training and experience necessary to safely install and maintain electrical systems. Attempting to perform electrical work without the proper training can be dangerous and may violate local electrical codes. The NEC provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical installations. These requirements are designed to ensure that electrical systems are safe and reliable. Electricians must be familiar with the NEC and any local amendments to it in order to perform their work safely and effectively. The NEC also covers specific requirements for different types of occupancies such as residential, commercial, and industrial buildings. These requirements may vary depending on the type of occupancy and the specific hazards present. For example, industrial buildings may have more stringent requirements for grounding and bonding due to the presence of heavy machinery and other electrical equipment. The NEC is a comprehensive document that covers a wide range of electrical topics. It is an essential resource for electricians, electrical inspectors, and other professionals involved in the electrical industry. Regular updates to the NEC ensure that it remains current with the latest technologies and best practices. The use of color coding for electrical wires is a fundamental safety practice. It helps to quickly and easily identify the function of each wire in a circuit. The NEC specifies the colors that should be used for different types of conductors, such as hot, neutral, and grounding wires. The color coding scheme helps to prevent accidental contact with energized wires and ensures that electrical systems are wired and maintained safely. The re-identification of white wires used as hot conductors is an exception to the standard color coding scheme. It is only permitted under specific circumstances, such as when a white wire is used as a switch leg or traveler. In these cases, the white wire must be permanently marked with black or red tape or paint to indicate its function as an ungrounded conductor. The re-identification requirement helps to prevent confusion and ensures that the white wire is not mistakenly identified as a neutral conductor. Electrical safety is a critical concern in all electrical installations. Electricians must take all necessary precautions to protect themselves and others from electrical hazards. This includes always energizing circuits before working on them, using appropriate personal protective equipment, and carefully verifying the wiring before energizing a circuit. Electrical work can be dangerous, and it's essential to follow all safety procedures to prevent accidents. The NEC provides detailed requirements for electrical safety, and electricians must be familiar with these requirements in order to perform their work safely and effectively. Grounding is an important aspect of electrical safety. It provides a path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and to energize the circuit. Grounding also helps to reduce the risk of electric shock. The NEC specifies the requirements for grounding electrical systems, and electricians must follow these requirements to ensure that electrical systems are properly grounded. Bonding is another important aspect of electrical safety. It involves connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to reduce the risk of electric shock and electrical fires. The NEC specifies the requirements for bonding electrical systems, and electricians must follow these requirements to ensure that electrical systems are properly bonded. Overcurrent protection is essential for preventing electrical fires and other hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of a fault. The NEC specifies the requirements for overcurrent protection, and electricians must follow these requirements to ensure that electrical systems are properly protected. Wiring methods are also important for electrical safety. The NEC specifies the types of wiring methods that are permitted for different applications. Electricians must use the appropriate wiring methods for each application to ensure that electrical systems are safe and reliable. The NEC is a complex document, but it is essential for ensuring electrical safety. Electricians, electrical inspectors, and other professionals involved in the electrical industry must be familiar with the NEC and any local amendments to it in order to perform their work safely and effectively. Regular updates to the NEC ensure that it remains current with the latest technologies and best practices. The use of arc fault circuit interrupters, or FSIs, is another important aspect of electrical safety. FSIs are designed to detect arc faults, which are a common cause of electrical fires. When an arc fault is detected, the FSI will trip and energize the circuit. The NEC requires FSIs in many areas of the home, such as bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to detect ground faults, which can cause electric shock. When a ground fault is detected, the GFCI will trip and energize the circuit. The NEC requires GFCIs in many areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Surge protection is also important for protecting electrical equipment from damage caused by power surges. Power surges can be caused by lightning strikes, utility switching, and other events. Surge protectors are designed to divert excess voltage away from electrical equipment, which helps to prevent damage. The NEC provides requirements for surge protection in some applications. Electrical inspections are an important part of ensuring electrical safety. Electrical inspectors review electrical installations to ensure that they comply with the NEC and local electrical codes. Electrical inspections help to identify and correct potential hazards before they cause problems. Electrical permits are typically required for most electrical work. Electrical permits ensure that electrical work is performed by qualified electricians and that it is inspected by electrical inspectors. The process of obtaining an electrical permit helps to ensure that electrical work is done safely and in compliance with the NEC and local electrical codes. Electrical codes are constantly evolving to reflect changes in technology and best practices. It is important for electricians and other professionals involved in the electrical industry to stay up to date on the latest electrical codes. Continuing education courses and other training programs can help to ensure that electricians have the knowledge and skills necessary to perform their work safely and effectively. Electrical safety is a shared responsibility. Electricians, electrical inspectors, homeowners, and other members of the community all have a role to play in ensuring that electrical systems are safe and reliable. By working together, we can help to prevent electrical fires, electric shock, and other electrical hazards. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. The presence of Salt Lake City, Utah suggests that the local electrical codes may have specific requirements or amendments to the NEC. It is essential to consult with local authorities and licensed electricians familiar with the Salt Lake City area to ensure compliance with all applicable regulations. Furthermore, the altitude and climate of Salt Lake City may influence certain electrical considerations, such as conductor and capacity rating for high temperatures or specific requirements for outdoor electrical installations. Always factor in these local environmental conditions when designing and installing electrical systems.